Have you ever had a moment that just felt wrong? A moment of déjà vu, so intense, so vivid, that it feels less like a memory and more like a rerun of a scene you've already played. Or perhaps you've experienced something stranger, searching frantically for your keys. You check the hook by the door 3 times, and it's empty. You search the rest of the house only to return in frustration and find the keys hanging exactly where you first looked, as if they just loaded into existence. They're looking at the bizarre rules of the quantum world, which sometimes behave more like the code of a video game than the solid reality we experience, but is instead an incredibly advanced computer simulation created by a civilization far more advanced than our own. It is a staggering, almost unthinkable proposition, and yet the clues, when you start looking for them, seem to be everywhere. In this hypothesis file, we will examine the evidence. We will trace the idea from its ancient philosophical roots to its modern scientific form. We will explore the clues hidden in the laws of our cosmos, and we will weigh them against the arguments that this is, and must be, the one and only real world. The file is now open. Are you ready to question everything? What if the speed of light isn't a physical barrier, but a processing speed limit? What if the smallest possible unit of space, the Planck length, is the universe's equivalent of a pixel? The ultimate resolution beyond which you cannot zoom? These moments are often dismissed as simple tricks of the mind, lapses in attention, or the brain's quirky wiring. We laugh them off, call them brain glitches, and move on with our day, secure in the reality we know. But what if they're not? What if that term glitch is more accurate than we think? The feeling of an odd coincidence, a strange pattern, a moment that seems to perfectly scripted it, a feeling that has been immortalized in our culture. What was once a fringe concept is now being seriously discussed by some of the most influential thinkers, scientists, and technologists of our time. When asked about the odds that our reality is a simulation, tech entrepreneur Elon Musk has said the chances that we are in base reality are 1 in billions. Astrophysicist Neil deGrasse Tyson has put the odds at 50-50, admitting that he can't find a strong argument against the possibility. They are not alone. A growing number of physicists, cosmologists, and philosophers are looking at the fundamental nature of our universe and finding things that look suspiciously digital. Call it a glitch in the Matrix, a nod to the iconic film that introduced a generation to a terrifying idea that the world we perceive as real is nothing more than an elaborate, computer-generated dream. In the film, a black cat walking past twice is the telltale sign that the code of the simulated world has been changed. It's a bug in the system, a crack in the facade that reveals the constructed nature of reality itself. This idea, once confined to the realm of science fiction and late-night philosophical debates, has broken free into the mainstream. They are pointing to the laws of physics, which are governed by elegant mathematical equations, almost like the programming of a cosmic computer. This is the simulation hypothesis. The theory that everything we know, every star, every planet, every person, every thought, and every emotion is not part of a physical base reality. Before there were computers, code, or virtual reality, there were philosophers in ancient Greece asking the same fundamental question. We are today. How can we be sure that the world we experience is the real world? The language we use may be new pixels, processors, rendering engines, but the suspicion that our reality is a convincing illusion is one of the oldest and most profound ideas in human history. Imagine, he says, a group of people who have lived their entire lives chained inside a deep cave. They are chained in such a way that they can only face a blank wall in front of them. What if we are the prisoners, chained in the cave of our own senses? What if everything we call the universe, the stars, the planets, the intricate laws of physics is nothing more than the shadows projected on the wall, a convincing but ultimately false representation of a higher, truer reality we cannot perceive? Behind the prisoners, a fire is burning. In between the fire and the prisoners, there is a raised walkway where people walk, carrying puppets and other objects. Descartes wanted to find a foundation of absolute certainty upon which he could build all other knowledge. To do this, he employed a method of radical doubt, deciding to reject anything that could possibly be false. He began by doubting his senses after all. They can be easily tricked. But he then imagined something far more powerful. He conceived of a malevolent entity, a malign or evil demon, whose sole purpose was to deceive him. This demon, Descartes imagined, could be creating a complete illusion of an external world. The sky, the trees, the feeling of the chair beneath him. Even his own body, all of it, could be an elaborate fabrication fed into his mind by this all-powerful deceiver. The fire casts the shadows of these objects onto the wall in front of the prisoners. The evil demon is simply an older name for what we might now call the super AI, the programmer, the system administrator of our reality. It's the idea of an external intelligence actively creating our world. But even in the face of this ultimate deception, Descartes found one thing he could not doubt: the fact that he was doubting. In order to be deceived, he had to exist as a thinking thing. This led to his famous declaration, cogito, ergo sum, I think, therefore I am. While this proved the existence of his consciousness, it could not prove the reality of the world around him. From Plato's shadows to Descartes' demon, humanity has always been haunted by the possibility that we are being fooled. The only thing that has changed is the technology we imagine is doing the fooling. For these prisoners, the flickering shadows are the only reality they have ever known. They give the shadows names, study their movements, and believe them to be real, tangible things, unaware of the true objects casting them. To understand the modern simulation hypothesis, we must first walk through the halls of an ancient archive. Starting over 2,000 years ago with the Greek philosopher Plato, he would be forced to turn around and see the fire, which would hurt his eyes. He would see the puppets and be told that these, not the shadows, are the true reality. He would be confused and in pain, and he would likely want to return to the familiar comfort of the shadow world he understands. If he were then dragged out of the cave entirely and into the full light of the sun, he would be completely blinded. But as his eyes adjusted, he would see the world for what it truly is: the trees, the sky, the animals, the sun itself. He would understand that his entire life had been spent watching a pale imitation of true reality. But if this freed prisoner were to return to the cave to tell his fellow prisoners the truth, what would they do? They would not believe him. Seeing that his journey into the light had ruined his eyesight for the darkness, they would think him insane. They might even try to kill him for threatening their perceived reality. In his seminal work, The Republic, Plato presents a thought experiment known as the allegory of the cave. Now, Plato asks, what would happen if one of these prisoners were freed? Plato's allegory is a powerful metaphor for the pursuit of knowledge and truth. But in the context of our hypothesis, the parallel is chillingly direct. Centuries later, in the 17th century, the French philosopher Descartes took this idea a step further. For centuries, the idea that our reality might be an illusion was purely a philosophical exercise, a thought experiment with no way to be tested or argued with logic. But in 2003, a philosopher at Oxford University named Nick Bostrom published a paper that would change everything. It assumes that our brains are, in essence, incredibly sophisticated biological computers. If this is true, then it follows that with sufficient computing power, consciousness could be artificially replicated or simulated. This isn't to say we can do it now, but that it is, in principle, technologically possible. It means that something, some calamitous event or existential threat, almost always prevents civilizations from surviving long enough to build these ancestor simulations. This means that advanced civilizations do exist, but they simply choose not to simulate their past. Perhaps they find it unethical to create conscious beings who can suffer. Perhaps they have different philosophical or recreational interests. Maybe it's just boring to them. Either humanity is on a path to near certain extinction, or our descendants will be fundamentally different and uninterested in their own past, or we are, right now, living inside a computer. The argument doesn't tell us which of the three is true, but it strongly suggests that the default assumption that we are real in the one and only universe is the least likely option unless one of the first two rather bleak scenarios is correct. If this proposition is true, then advanced life is out there, but they aren't creating simulated worlds like ours. In this case, we are likely living in the real, base reality. This could be a nuclear war, an asteroid impact, uncontrollable artificial intelligence, or a climate catastrophe. This is the stunning conclusion if the first two propositions are false. If civilizations do regularly survive to a post-human stage, and they are interested in running these simulations, then the math becomes undeniable. A single post-human civilization could run billions upon billions of ancestor simulations. Over time, the number of simulated realities would vastly outnumber the one single base reality. The number of simulated consciousness is simulated. People like us would be trillions of times greater than the number of real people. If this is the case, then based on pure, simple probability, it is almost a statistical certainty that we are among the simulated masses and not the original creators. If this proposition is true, then we are likely real, but we are also likely doomed. If you accept this single premise, then Bostrom's logic becomes incredibly difficult to escape. The paper titled, "Are You Living in a Computer Simulation?" took the ancient question and forged it into a formidable piece of logical reasoning. Eventually, such a civilization might become posthuman, a stage of development where they possess technology so powerful it would seem like magic to us. They could harness the energy of entire stars, manipulate the fabric of space-time, and, most importantly, for our purposes, build computers of unimaginable power. Bostrom then asks, what might such a powerful civilization do? One very likely possibility is that they would run ancestor simulations. Just as we create video games like The Sims or run complex computer models of weather patterns or galaxy formation, posthuman civilization might run vast numbers of perfectly detailed simulations of their own ancestors. People like US2 study their history, their sociology, their art, or perhaps for reasons we can't even comprehend. These wouldn't be simple video game characters. They would be fully conscious, sentient beings who believe their simulated world is completely real. Bostrom didn't claim to have proof that we are in a simulation. Instead, he presented a brilliant and deeply unsettling trilemma, arguing that based on a few reasonable assumptions, one of three very specific and very strange conclusions must be true. The entire argument rests on one fundamental assumption, that consciousness is not some magical, ethereal substance, but is instead the product of complex information processing. He asks us to imagine a future for humanity or any other intelligent species where technology continues to advance. With this setup, Bostrom presents his trilemma, argues that one of the following three propositions must be true. First, a fraction of human-level civilizations that reach a posthuman stage is very close to zero. This is the Great Filter hypothesis. Second, the fraction of post-human civilizations that are interested in running ancestor simulations is very close to zero. Third, the fraction of all people with our kind of experiences that are living in a simulation is very close to 1. This is the power of Bostrom's argument. It forces us into a corner. If we accept Nick Bostrom's argument that we are most likely living in a simulation, the next logical question is, would there be any way to tell? Would the programmers of our reality leave any clues in the source code? Would there be any telltale signs in the fundamental laws of our universe that suggest it is a constructed artifice rather than a base reality? The very fact that our universe is so orderly, so logical, and so perfectly describable by mathematics can be seen as evidence of this code. But as we learned in the 20th century, this is an illusion. From a distance, the image appears smooth and continuous. But if you were to zoom in far enough, you would see that it is composed of millions of individual discrete dots of light, pixels. The pixel is the smallest possible unit of that image. It cannot have half a pixel. It is the fundamental resolution of that digital reality. Now think back to the Planck length. Could the smallest possible unit of our universe be, in effect, the pixel of our reality? The fact that space-time appears to have a finite resolution, a point beyond which you cannot zoom, is a feature that is not required for a base reality, but is absolutely essential for a simulated one, which would need a fundamental grid, a pixel size, to operate. At the quantum level, reality is not continuous, it's quantized. In video games, to save processing power, the game engine only renders in full detail the parts of the world that the player is actively looking at. The rest of the world exists as a simplified set of data and probabilities until it enters the player's view. Incredibly, the universe seems to do something similar. Quantum mechanics tells us that a particle, like an electron, doesn't have a definite location until it is observed or measured. Until then, It exists only as a wave of probability. Could this be the ultimate cosmic cheat code? A way for the simulation to save processing power by only rendering reality when a conscious entity is looking at it. These features of our universe don't prove the simulation hypothesis, but they are undeniably suspicious. They are the exact kinds of shortcuts and fundamental structures you would expect to find if our world was not born from a random Big Bang, but from a deliberate keystroke. This means that things like energy and light don't come in a smooth, infinite stream, but in tiny, discrete, indivisible packets called quanta. You can have one packet of light, or two, or three, but you can never have one on a half. This quantization extends to the very fabric of spacetime itself. According to our current understanding of physics, there is a minimum possible length, a fundamental unit of distance below which the concept of space itself ceases to have meaning. It is called the Planck length. If the universe were a chaotic, random base reality, there's no inherent reason it should be so comprehensible to us. The mathematical elegance of physical law could simply be a sign of an elegantly written computer program. But the clues don't stop with the broad mathematical structure of the cosmos. They get much stranger and much more specific when we zoom in to the smallest possible scales of existence. Proponents of the simulation hypothesis believe the answer is yes, and they argue that the first and most profound clue is found in the very language the universe is written in: mathematics. Think about it. From the graceful arc of a thrown ball to the majestic orbit of a planet around its star, the behaviors of objects in our universe can be described with stunning precision by mathematical equations. The deeper we delve into the nature of reality, the more mathematical it becomes. Einstein's theory of relativity, which governs the grand scale of space-time and gravity, is a set of elegant tensor equations. Quantum mechanics, which governs the bizarre world of subatomic particles, is built on a foundation of wave functions and probability matrices. It seems that everything is interconnected by a hidden layer of logical mathematical structure. For many physicists, this is a beautiful and mysterious fact of our existence. But for a simulation theorist, it's exactly what you would expect to find. A simulated reality, by its very nature, must be governed by a set of rules, an underlying code that dictates how every element within it behaves and interacts. In our everyday world, things appear smooth and continuous. To understand the significance of this, think of the screen you are watching this on right now. This leads to another bizarre feature of the quantum world, the observer effect. If our universe is built on a grid of cosmic pixels, as the Planck length might suggest, are there other system limitations we can observe? If we are living inside a vast computation, does that computer have a finite processing speed? That speed, denoted by the letter c, is precisely 299,792,458 meters per second in a vacuum. According to Einstein's theory of relativity, nothing with mass can ever reach this speed, and nothing, not even information itself, can travel faster. These are the bugs in the software, the glitches in the matrix that many people report experiencing. But the actual spelling has always been Berenstain, with an A. Many can quote the iconic line from Star Wars as Luke, "I am your father," when Darth Vader actually says, "No, I am your father." The conventional explanation for the Mandela Effect is a combination of psychological phenomena, false memory, confabulation, and the way misinformation can spread and reinforce itself through a culture. But the simulation hypothesis offers a stranger, more tantalizing explanation. What if these aren't errors in our memory, but errors in the code? What if the programmers of our reality occasionally make retroactive changes, retcons, to fix a bug or alter a variable? Perhaps they changed the spelling of a name or tweaked a line of dialogue, and some of us are left with a residual, cached memory of the previous version of reality. The most famous of these is the Mandela Effect. The term was coined by paranormal researcher Fiona Broome. After she discovered that she, an intense moment of déjà vu, could be the system reloading a save point after a minor crash. A wild, improbable coincidence could be a sign of a lazy programmer, forcing a narrative event to occur. While these anecdotal experiences are easily dismissed, they fit a pattern. They're the kinds of oddities you might expect to find if the smooth, continuous reality we take for granted is actually a piece of software that, like any other, is prone to the occasional bug. And many others shared a clear and distinct memory of South African leader Nelson Mandela dying in prison in the 1980s. This, of course, never happened. Mandela was released in 1990 and lived until 2013. But the number of people who share this false memory is staggering. It's the ultimate speed limit for causality, the rate at which effects can follow their causes through spacetime. For physicists, this is a fundamental property of the universe. But for a simulation theorist, it looks suspiciously like a processing constraint. Proponents of the simulation hypothesis point to one of the most fundamental and unshakable laws of our universe as a potential answer: the speed of light. The computer running it has a processor with a specific clock speed, which dictates how quickly it can perform calculations, update the positions of objects, and render the graphics on screen. There is a maximum speed at which the system can update its own state. If you could move through the game world faster than the processor could render it, the simulation would break down. Now, apply this to our universe. If reality is a simulation running on some form of vast computational hardware, it would need a maximum speed at which information could be passed between any 2 points in the system. The speed of light, see, is a perfect candidate for this ultimate processing speed. It is the refresh rate of our reality, a built-in limitation to ensure the simulation remains stable and consistent. In our reality, there is an absolute cosmic speed limit. Think of any complex video game or virtual environment. Beyond the hard limits seemingly coded into our physics, there are other clues that might be considered less scientific, but are far more personal and unsettling. And it's not the only example. Millions of people remember the popular children's book series as the Berenstain Bears. With an E, these glitches could be signs of the simulation's code being patched and updated in real time. The clues are tantalizing. A universe built on math, with a finite resolution and a cosmic speed limit. Populated by beings who experience strange glitches in their reality, the case for living inside a simulation can seem compelling, even seductive. But a proper investigation requires us to do more than just look for supporting evidence. It requires us to actively challenge the hypothesis. If you were to find some evidence that seems to contradict the theory, the simulators could simply alter the simulation to hide that evidence. If our universe is a simulation created by a post-human civilization, it is reasonable to assume that those simulators exist within their own universe, with its own laws of physics. Is it actually possible to build a computer powerful enough to simulate an entire universe like ours? The scale of the task is almost beyond comprehension. But even with such cheats, the complexity remains staggering. These powerful rebuttals, the unfalsifiable nature of the hypothesis, the problem of infinite regress, and the question of computational impossibility are why most mainstream scientists remain deeply skeptical. While the clues for simulation are intriguing, they are far from definitive, and the arguments against it are grounded in the core principles of logic and science. To accurately simulate just the quantum interactions within a single human brain, let alone the brains of all 8 billion people on Earth simultaneously, would require a computer of astronomical size and power. Some physicists, like Seth Lloyd of MIT, have tried to calculate the computational limits of the universe. Their findings suggest that the amount of energy and matter required to build a computer capable of perfectly simulating our universe would be greater than all the energy and matter contained within the universe itself. But is their universe the true base reality? Or is it also a simulation, created by an even more advanced civilization? And what about their simulators? This line of questioning leads to a potentially endless chain of simulations nested within other simulations, like Russian dolls stretching on for eternity. This doesn't disprove the theory. Perhaps there is a base reality, the very top of the chain, but it does mean that the hypothesis doesn't actually solve any fundamental questions about existence. It simply replaces the mystery of where did our universe come from, with the equally profound mystery of where did the top-level base universe come from. If you were getting too close to the truth, they could wipe your memory or simply turn the simulation off. The hypothesis can explain away any and all counter-evidence as being part of the simulation itself. It's a perfectly sealed circular argument, because it makes no testable predictions and cannot be proven false. Many scientists and philosophers argue that it's not science. But metaphysics is a fascinating philosophical puzzle, but one that lies outside the realm of physical proof. Science and philosophy are built on skepticism, and when we turn a skeptical eye to the simulation hypothesis, we find that it faces several powerful and potentially fatal criticisms. The first and most significant hurdle is that the theory may not be a scientific theory at all. According to the philosopher of science Karl Popper, a key ingredient of a valid scientific theory is falsifiability. This means that there must be some conceivable experiment or observation that could prove the theory wrong. For example, Einstein's theory of relativity made specific, testable predictions, like the bending of starlight by gravity. If astronomers had looked and found that starlight wasn't bent, his theory would have been falsified. The simulation hypothesis, however, appears to be completely unfalsifiable. How could you ever design an experiment to prove you are not in a simulation? The second major problem is one of infinite regress, a concept often illustrated by the phrase turtles all the way down. Finally, there is the sheer mind-boggling question of computational feasibility. Of course, a simulator could use shortcuts. As we've discussed, they might only render parts of the universe that are being observed. So where does that leave us? On one hand, we have a universe that appears to be written in the language of mathematics, with fundamental limits on space and speed that look suspiciously like the constraints of a computer system. Let us, for a moment, entertain the idea. Let us assume the hypothesis is true. What then? If you were to wake up tomorrow with absolute proof that your life, your memories, and your world are all part of an elaborate computer simulation, what would change? Does it matter? Its power lies in its ability to serve as a modern lens for humanity's oldest and most fundamental questions. It forces us to confront the nature of consciousness, the definition of reality, and the search for purpose in our lives. It is a tool for intellectual humility, a reminder that our understanding of the universe is incomplete, that our perceived reality may be far stranger than we can imagine. On the other, we have powerful logical arguments that suggest the theory is an unfalsifiable, perhaps impossible piece of philosophical speculation. Perhaps the best response is to live a life that would be worth simulating in the first place. A life filled with curiosity, compassion, creativity, and meaning. A life so interesting that, somewhere in a higher reality, a programmer might lean in a little closer to their screen to see what you do next. The hypothesis file on our own reality remains wide open. This reality, simulated or not, is the only one we have ever known. The joy you feel spending time with loved ones is real to you. The pain of loss is real to you. The beauty of a sunset, the taste of your favorite food, the thrill of discovery, these experiences are not made less meaningful simply because they are generated by a sophisticated program. A simulated friendship is still a friendship. A simulated act of kindness is still an act of kindness. The source of our reality does not have to dictate the value we find within it. Perhaps the most meaningful response is to simply continue living, to continue creating our own purpose in the only world we have access to. We are at an impasse. With our current knowledge, we cannot definitively prove or disprove the simulation hypothesis. We are left staring at the shadows on the cave wall, with no way to know for sure if there is a world of light beyond them. This brings us to the final, and perhaps most important, question. There is a compelling argument that it doesn't matter at all. But there is another perspective, one that argues that it changes everything. If our world is a simulation, it implies that it might have a purpose, an objective set by our creators. Are we a science experiment designed to study the emergence of consciousness? Are we a historical reenactment? A digital museum of a long-lost era? Or, in a more unsettling thought, are we merely a form of entertainment, an incredibly advanced video game being played by beings in another dimension? If there is a game, does it have rules we should be trying to figure out? Is there a way to win? This perspective could imbue our lives with a new, external purpose, or it could fill us with a profound sense of cosmic insignificance. Should our goal be to live a good life within the simulation, or should it be to try and make contact with the programmers, to attempt to break out? Ultimately, the true value of the simulation hypothesis may not be in finding out whether it's true. Perhaps the goal isn't to prove or disprove the simulation. If you want to continue questioning the nature of reality with us, subscribe to the Archivist and click the bell so you never miss a file.